So hello everyone, in this video we are going to discuss the question number 11 of exercise 16.1 polity chapter. So see, if you read out the question first, so here it's given that we are going to select 3 bulb, right, from the lot of bulb, right. Each bulb is tested and classified as defective or non-defective, right. So write the simplest case. Now see, in this case you are going and you are selecting the first ball and then test it, let us suppose, and keep it. Second ball tested, then third ball tested. So what are the possibility in this case? We have total a lot, and in lot the lots of ball are kept. Let us suppose a box or whatever you can think, a bag, whatever you can think. So we have a lot of bulb, right? So we have lot of bulbs here, bulbs, so many bulbs are there. So many bulbs are there, right? So you are going and you are selecting one bulb, and if it is defective, you are selecting one, then test it. If it is working, then write N on that. If it is not working, then write D on that. That is defective one. So what is the possibility here? So the sample space can be, in this case, sample space. For this case will be what? See, let us suppose we have selected the first ball and tested it, and it found to be defective. Then what you will do? You will select the second ball, again you test it, let us suppose, again found to be defective. Then what you will do? You will take the third ball, because you have to take total 3 ball, again test, let us suppose, just assuming there that we found to be defective. So this is the one case may be possible. What can be the second case? That the first ball is defective, second is defective, but third one is not defective. This is the one of the case. Third case may be like that the first ball is defective, but second ball is non-defective, and the third ball is defective. Now see, so these two are different case. Why different case? Because here the non-defective ball we are getting in the third, when we are selecting the third ball, but in this case the non-defective ball we are getting the second selection, right? So in this all case we have to contain different one. Then likewise N, D, D maybe means first ball is non-defective and the second two is defective. Next case we got here N, N and D, that is the first two selection is non-defective and the third one is defective. Then it may be like that N, D and then N. Then it may be like that what? It may be like D, N and N. And one more case is possible, that all the bulb are non-defective. So this is the total 8 cases possible with the 3 bulb if we are selecting from a lot, right? So what is the total sample point? If you summarize, what is the sample point here total? So number of sample point. What is the total number of sample point? Sample points. So total 8 sample point, right? Or you can write the total number of elements in sample space is what? 8. Total 8 elements are there in the sample space. So hopefully you get the concept of this question, how to add the sample space. Let us move to the next question, question number 12. So see the question number 12 here. A coin is tossed. If outcomes is head, a dice is thrown. Okay. If the dice shows up an even number, the die is thrown again. Okay. I mean, what is the simplest space for this experiment? See, in such type of questions, and I think almost all the questions, if you can apply this rule, you can apply always. So what is the rule here? That is on the tree diagram. So let us discuss that one. So here we are writing the solution for this question number 12 here. Question saying a coin is tossed. So let us make the diagram. If we are tossing a coin, let us suppose this is the coin here, coin number first, this is the coin. So what is the total possible outcomes? It may be here head or it may be tail. Two possibility. Coin may shows head or coin may shows tail. This is the case, right? Think, just imagine the situations in your mind. You will get very clear, very simple chapter polity. But if you think, right, think the situations. So when we are tossing a coin, 2 outcomes, either head or tail. Now see the next, read the next one. See, a die is thrown. Okay, kab? If then see, if outcomes is head, then a die is thrown. Let us if you are tossing a coin and if outcomes coming is head, then you are going to throw a dice. Okay, let us suppose this case we are discussing. So we have thrown a coin and outcomes here we are getting a head. Then what we have to do now? You are going to throw a dice. So when we are throwing a dice, how many total outcomes are there? Total 6 maybe outcomes. 1, 2 maybe get, 3 maybe get, 4 maybe get, 5 maybe get, or 6 maybe get. So these are total possible outcomes when we are throwing a dice. 1, 2, 3, 4, 5, 6. We are discussing this case that if we have tossed a coin and we are getting the head. If we are getting the head, we have to throw a die also. Now see again next line. If die shows up an even number, right? So if this thrown dice is shown even number, then what we have to do? Then die thrown once again, right? So see, if die thrown even number, let us suppose this case, right? That the dice throws 2. So if this case is there, then we have to throw dice once again. That is 1 here, 2, 3, 4, 5, or 6 maybe get, right? This is the case. Or if you are let us suppose 4 here on the dice, then again you have to throw the dice 1, 2, 3, 4 maybe, 5 maybe, or 6 maybe. Or let us suppose you are getting 6, again the even number, so again you have to throw the dice 1, 2, 3, 4, 5, or 6. These are the possible outcomes on the dice 1, 2, 3, 4, 5, or 6. Or with this combination here 1, 2, 3, 4, 5, or 6. Similarly here 1, 2, 3, 4, 5, or 6. So these are the case maybe. Now what happens if coin shows tail? Nothing to do. If coin is showing tail, then that's only you have to stop the experiment. If coin showing head, then you have to do this much. So write all the branch, you will get the answer. So what is the sample space in this case? Sample space. So what is the sample space here? You can see. So this is head, right? So head and means coin shows head. If coin showing head and you have thrown the dice and dice showing in this case 1, so are you throwing 1 again? No, you are going to throw again only next time only when your dice showing the even number. So h1 is only that one. Let us suppose your coin shows head here, means we are writing this branch, this head, and your dice shows here 2. Your dice shown here 2. So when the dice showing 2 means this is even number. So you have to throw the dice once again. Means if h and your the second toss, that is your dice showing 2. So what you have to do now? You have to do the you have to throw the dice once again. Means here maybe this case, that is h2 or 1 maybe, this possibility that it may be like that h2 or 1, or it may be h2 or it may be 2 from here. So it may be like that h2 2, it may be h2 3, it may be h2 4, it may be h2 5, or it may be what, h2 6. So we have written all the combination with h2 and this all 6, 1, 2, 3, 4, 5, 6. This we have written here, right? Fine. Now see, let us suppose at this case your coin shows here head and your dice shows here 3. So if showing 3, that is not even number, so no need to do the next case. Here maybe our coin shows here head and this dice shows here 4, right? So if shows 4 means this is even number, so you have to throw the dice once again. So again 1 to 6 cases possible. So h4 1, h4 2, h4 here 3, or h4 4, h5 h4 5, h4 5, or h4 6. So this all 6 cases we have counted with this 4. What happen if the coin showing head and your die showing 5, nothing to do because 5 is not an even number. You are throwing the dice only when you are getting an even number here on the second dice throw. Next, let us suppose here you are getting here head and die showing 6. So 6 as an even number. So again you have to throw the dice, means you can get 1, 2, 3, 4, 5, 6. So H6 1, H6 2, or H6 3, or H6 4, or H6 5, or H6 6. So these are the possibilities we have written when coin shows head in this case. Now see what happens if coin showing tail, nothing to do. And we have to do the experiment only in the case when we are getting the head. So this is the case here. So this is the all its sample space of these questions. Okay, fine. Okay. So see in this question number 13, what question given? So here it's very easy questions. See, here we have a box, right? And in this box actually 4 slips are here kept, right? So let us suppose this is the slip number 1, slip number 2, slip number 3, and slip number 4. And all slips retain something, that is 1 is written here, here 2, here 3, and here 4. So all 4 things are written on the slip separately. Now one person went and mixed all the slips, and then what you have to do, one person doing an experiment that he, without looking to the slips, picking one slips and then kept, then second one, then kept. This experiment they are doing. So what is the total sample space in this case form? Got the question or not? Repeat once again. See, you have a box, right? And in that 4 slips are kept. Each slips written 1 and on other 2, on other 3, and other 4. So 4 number are written separately on them. Now we have to take out 2 slips from there one by one, without replacement. See, this is the very important word. Without replacement means when we are taking one slips, now you are not going to put in the box. We are taking separately. That is the not going to replace there. Okay, now so see what the total sample space in this case. So solution we are going to write. We have to write the sample space. So sample space. So what may be the case? See here. First, we can get 1, right? And second, we can get 2. 1, 2 we can get, right? We can get 1, 2. Here we can get 1 or 2, okay? Or we can get 1, 3. We can get 1, 4. So this is the possibility with 1, 2, and 1, 3, and 1, 4, right? Similarly, if we take 2, let us suppose first if we taken then we get 2. So with 2 also we can get 1. So see, 1, 2, and 2, 1 are different. Why different? Because in the first when we taken the slip, then in the first case we are getting the 1, and the second times we are getting the 2. But here the first time we are getting the 2, and second time we are getting the 1. So both are the different cases, right? Then similarly 2 or 3 we can get 2, 3, right? Then 2, 4 we can get. Similarly, let us suppose you got the first drawn, you get here 3. This is 3, or 1 you can get, 3, 2 we can get, 3, 3 is not possible, only 1, 3 is there. So 3, 4 you can get. Similarly, 4, 1 you can get, 4, 2 you can get, 4, 3 you can get. So this is the total possibility here when we take 2 card from the box one by one. Important one, that we are taking one first, then second first. That's why here order is matter, right? That on the first, if we are taking the first slip, then what is coming, and next when we are taking the second slip, then what is coming. So that is order is matter here. That's why 1, 2, and 2, 1 are different. Got it? So yes, so this is the simplest space here. So thank you so much. The next questions we will see in the next video. Thank you.